Hi, it's Mr. S, and today's topic is about cylinders, cones, and spheres. So it's solids related to circles. The objects around us, the cylinders, cones, and spheres, I put examples of each solids that you might see around you. So, for example, cylinders, you might see cans, something that has food in it or whatever, paper towel, toilet paper, are types of examples of cylinders. Cones, like construction sports cones that you see if you play sports, if you ever drove outside and you see those orange, reddish cones. Megaphone, like this one. Funnel that you might use for in your chemistry class or whatever, or you use it for when you pour something into the whatever. A funnel. So that's examples of cones. Now the spheres could be ball, any ball, like not any, but like basketball, soccer ball, baseball, tennis, bowling. Those balls you can use. That's a type of spheres. And you might have more. What do you think? What do you know of? You probably know something that I didn't even realize. So before we get into it, this is just kind of prior knowledge activity. Just understand. I'm looking at what you know about it already. And here are the topics I will do today. I'm going to introduce the solids, the definition kind of thing, what's the characteristics, and I'm going to also do the volume of each solid. Now the solids I'm going to do is the cylinders, cones, and spheres. I'm going to do classroom suggestions, which I did in not the previous video, but 2 or 3 videos before, which I did with the prisms and pyramids. And then I'll also have another online resource that I want to share. So let's get into cylinders first. Cylinder is a circular prism, kind of like you have the base as a circle. Here it is, right here, and on this side as well. And that base is a circle, and it's stacked up, kind of like up or whatever. And think of it as a stacked CD case. It doesn't have to be CD, but circular paper or whatever, the plane stacked up, making a cylinder. The volume is base area times height. Base area, so the area of that circle times the height. The next one is the cone. Cone has a base, it's a circle again, and has the apex, which is this vertex right here, where all the points meet here. And the volume is 1/3 of the base area times the height. Now 1/3 of the base area, again base area is the area of a circle, height is from this, base area, the height was from this point right here in the middle of the circle to the apex. Just straight up to the apex. And the last solid is spheres. It's a round solid. Every point on the surface is equidistant to the center. That means the point on the surface, like think of the outsides, is equidistant. That means same distance to the center of the sphere, which is going to be inside the sphere. Now I'm rotating this soccer ball because just rotating this sphere is not going to be helpful visually. So anyway, the volume is 4/3 times pi times the radius cubed. Last video maybe, video about circles, I did description about pi. If you want to look at that, please check it out. And there are different derivation of the volumes of these 3 solids. Now the cylinder, like I said earlier, is what I think of as the base area stacked up in it doesn't have to be up, but stacked in one direction. So you have a circle and it's stacked up. Now looking at cone, I'm comparing cone and cylinder for now. Cone and cylinder, looking at a cone has a same base area and the height. If you compare these two, same base area, same height, it's going to be 1/3 of a cylinder. The volume will be 1/3 of a cylinder. You can look compare that looking at a formula of each of the two solids. You can see that cone, the formula of the cone has 1/3 in front of the equation, while the cylinder only has base area times height. Looking at sphere, now comparing sphere and cylinder, think of it as like a sphere inside a cylinder, and it's going to be 2/3 of a cylinder. The volume of a sphere is 2/3 of a cylinder. Now, you'll be like, where did you get that numbers from? I mean, that's not a kind of really about derivation. Now, this website, Math is Fun, will explain, is explaining the derivation or the explanation of the volume. So this website right here, actually this page, Solid Geometry, is going to be helpful resource for any of the solids that you might be studying, like cubes, these things, prisms, pyramids, cuboids, other stuff like spheres, cylinders, cones that I just did, torus. There are other stuffs in here. Now I'm gonna go to the cone, sphere, and cylinder. Now, everything is here, actually. Now, if you click each of these, like cylinder, it has the blue background and the underline with the blue font right here as well. You can click those and see each of the shapes. Now it says spin, I don't want the spin, so maybe like this. So you can actually look at the description of each solids in here. It's going to talk about different types of cylinder, surface area, volume, all that stuff. Anyway, so, and this website is actually doing the cone versus cylinder, sphere versus cylinder, just like I introduced in the previous slide. Now, you might be thinking, well, what about cone and sphere? That is something that I would like to investigate. You might want to investigate that as well. Actually, there is a question that's asking similar stuff. What is the relationship between the volume of a cone and half a sphere? The hemisphere? This is something like, if you're a teacher, you want actually to have the students investigate instead of just giving out to the students. See, like for example, the cylinder have the same radius, same height, and looking at the volume, it's pi r squared h, height as an h, and 1/3 of pi r squared times h. Pi r squared is the base area. Base area, the area of a circle. Pi times radius squared. And comparing those, it's 1/3. Volume of sphere and cylinder. Now to put this sphere inside the cylinder, the height is actually 2r. And comparing these two numbers, it's going to be 2/3 of a cylinder. And other stuffs like here's the result in conclusion, and they're also doing the surface area as well. Well, that's about it. And anyway, so here, this website, the Math is Fun, is going to be one resource that you might want to look at when you're doing solids. Right? So here is a classroom suggestion that I've done earlier, in the video previous videos, is to have some solids for students to actually touch and feel, instead of having it on the paper, like on a screen or on a textbook. The reason is because it's going to be hard. It's really hard for students, even us adults, to imagine the 3D figure in our head. So maybe you can, if you're a teacher and you are doing solids, you might want to have set of solids for each student, if not like each group, or have one for classroom and put it around the classroom so that students can actually walk around and touch and feel the solids as they do solving problems or whatever. And here are a couple of more solids that I just want to share, just to show. This thing right here, it's a water bottle. What I have right here, I'm not trying to cover up the label. I have a water bottle right here, and I think you can see from here, maybe right here. It's a cylinder on the base, kind of cylinder on the base, and right here it's kind of like a cone, and then the top of the cap portion is another cylinder. It's kind of like a composite figure that I've done in the 2D plane. Now it's 3D. Like here, cone plus cylinder. Right here, it's a bathtub. Maybe looking at this stuff, it's not really a prism. It's more like a, I don't know how to call this. But it looks like the top part and the bottom looks like the surface area is a little bit different. I feel like this top is bigger than the bottom. I just feel like it. Anyway, house. I don't know what this is called. I don't know what shape it is. And here's the cylinder that you use in science classes. Alright, so that's the end of the video. I hope this video was helpful. If you think so, I would like for you to like the video, leave a comment, and subscribe my channel. And I'll see you in the next video. Bye bye.